morning. Once again I welcome you to this lecture series Foundation Engineering, and as I have mentioned from the beginning that I will be doing quickly review on soil mechanics, and today is the fifth part, and where I will talk about the compressibility of soil. And this compressibility means what? Actually, at the beginning I have told that any material if you apply load, then it will subject it to compression or elongation, particularly if it is a elastic material like a rod suppose, and if you pull by a load from the both ends, then it will be elongated, or if you push by from the both ends, then it will be shortened. So, this is because of the elastic properties of the material. And when you talk about the soil not only behave elastically, but also will have another mechanism for compression of soil. As I have mentioned you that the soil consists of solid particles and voids, and these voids when is too much is there, then the soil will be having larger volume, and when it will be having less voids, then it will have lesser volume. So, as a result, soil in the natural state will have both voids and solids, and when we will apply load, then there will be chance of reducing the voids, and by that way the volume will be reducing. And this volume reduction can be done in two different ways. One is actually by compaction, that immediately you apply the load and then force the particle to come closer, and then by that way reducing the void ratio. That is one way of reducing the voids. And another thing happens in saturated fine grained soil, where when we apply load, and then because of the incompressible nature of both soil and solid particles, then there will be development of excess pore water within the void spaces, and this excess pore water pressure cannot stay for long. They will always have tendency to dissipate, and water will come out and pressure will be reduced. So, the soil mass, within the soil mass there are number of voids, and those interconnected void spaces will be acting as channel, and through that water will pass when it will be subjected to a load. So, that is the another mechanism how the volume change take place, and another mechanism is elastic. So, these two examples are here. When a large wheel load rolling along a roadway resting on clay will cause an immediate settlement, which is recoverable once the wheel is passed. That means, when it you might have noted, when there are trucks are moving on the road, or even your trains moves on the railway track, then you will see there will be depression immediately, and when wheel passed away, then the place, and then again it will be coming back almost in the original position. This is because of the elastic nature of the material, and whereas if you keep that wheel load for a long time on a fine grained soil, then there will be another way the soil will deform, that is actually consolidation, which I have just explained briefly. So, this consolidation means what? Actually, that when you apply load, then pore pressure will develop, and then slowly the dissipation of pore pressure, and then change of volume. That is the thing happening in the soil. So, this is suppose a particular soil sample. We generally conduct the test in the laboratory by preparing a sample, and we put it in the saturated condition, and then we apply load. And when we apply load, then immediately, as I have mentioned, that within the soil mass, this is the soil mass, suppose there are a number of voids, and those voids are filled up with water, and that water will be pressurized when we apply load. And this pressure will not sustain for long, because of these interconnected void spaces through that water will seep, and as a result the pore pressure will reduce, and when pore pressure will reduce, then the whatever load you have externally applied, that load will come to the soil grain, and that will cause you the compression of the soil, and the compression is actually measured by void ratio, that I will discuss subsequently. And again this consolidation again is not a one time phenomena. Suppose a soil is there, saturated soil, and you have applied 100 ton or 100 kilonewton load, then under this 100 kilonewton load, whatever excess pore water pressure develop, and if it dissipates, that is the end of consolidation under that load. And again after that another 100 kilonewton load if you apply, again you will start consolidating, and of course rate of consolidation may become less, because soil already consolidated. Similarly, after second set of loading, when the completely pore pressure dissipated, then that is the end of consolidation under second set of loading, and then again if you apply another load, then again pore pressure will develop, again dissipation of pore pressure will take place, and again consolidation will take place. Like that, if that means it is consolidation under certain load. It is not a that means I have applied a load and consolidated means that soil is ultimate consolidation is happened, that is not true. Under certain load, whatever possible, that consolidation will occur. Again if you apply more load, then again will consolidation will take place, but again second time, third time, fourth time if you go subsequently, the amount of consolidation settlement may reduce, because already it is consolidated and got compacted. So, that is the way if we do that, this can be visualized like that under load P 1. Suppose this is the compression under over time, again if I put P 2 here, then under that there will be compression over time. So, when you go the P 1, P 2, P 3, if it is same, then when you go towards end, the time taken by this same amount of compression will be more, because of the soil getting compacted, and interconnected path will be narrow and dissipation will be slow. As a result, when you will go towards a later stage, your compression rate will be reduced. And that, as I have told you, that this compression will be measured by volume void ratio change actually, because as I have told you that if the soil is visualized like this in a particular condition, suppose this is the solid soil total volume, and if this is the solid and this is suppose void, this is void and this is solid, and this void will be reduced. And our definition of void ratio is volume of voids V V by V S. So, V S is unchanged. So, V V is changing. So, void ratio will be changing. So, that is what we generally this will help us to study some of the things. So, because of that we the volume change we measure by change in void ratio. So, like that if you see the P 1, P 2 like that, if you go on increasing like this, and then void ratio will be changing, and of course, at lesser load void ratio will be high, and when you will be increasing the load, then subsequently void ratio will be reduced. So, this is E 1 will be greater than E 2, like that. Similarly, if I say this is the one E 3, again it will be E 3 again will be less than E 2. So, like that with increase of load, then void ratio will be slowly decreasing, and this actually sometime the E versus P curve it is called, and slope of this curve, that is d by dp is A, and then from there you can get a parameter that is called A over 1 plus E, and that is defined as MV, and if you know the MV of the soil, then we can find out the total settlement as MV dp into H. Suppose this is a soil layer like this, and suppose the property of the soil or volume compressibility is mv, and suppose dp pressure is applied at the middle of the clay layer and thickness is h. If thickness is h and pressure applied at the average pressure applied over the layer is dp, average pressure, thickness is h and mv of the soil layer is given suppose, then we can find out under this dp pressure how much total compression will take place or settlement will take place. So, that this is the expression. This is one way of calculating the amount of consolidation, and for finding out this consolidation settlement, what you need to evaluate for the soil, you have to evaluate for the soil mv property. How to find out the mv? You have to you can apply suppose P1 load, and then you can see at the end what is the void ratio. Then you apply P2 load, you can see at the end of what is the void ratio. P3 load, at the end of this consider what is the void ratio. Like that, number of loads you apply and corresponding void ratio you get, and then E versus P if you plot, and then you take 2 points, suppose this 1 and 2, and then you can see this is actually DE and this is DP. So, DE by DP is your A, and A by 1 plus E is actually your MV, and if you know this MV, then you can find out the consolidation settlement by this expression. And then another thing is observed that when E versus P, if you plot, it is a curved. This is the one I have shown in the previous slide, and your not linear, and several investigators observed that when E versus log P plotted, that means the under application of the load P, suppose whatever void ratio if you note, and number of them if you get, and then finally P if you express in log P, and that means P if you plot in a semi log log scale and void ratio in the normal natural scale, and then you see that this curve become linear. And once this become linear, then again from here also change of void ratio can be obtained. Suppose this was E 1 and E 2. So, E 1 minus E 2 is nothing but delta E that can be obtained, and to obtain this what I need to know? I need to know this slope, and how to this slope is called actually CC or compression index, sorry not compression index, yes compression index CC, and you can see that suppose I want to find out initial void ratio was E and then final E naught and final void ratio E, then E will be equal to original void ratio minus CC multiplied by log original pressure and increased pressure. This is the P2 suppose, and this is suppose P1. So, this ratio that is log scale, so that is in this log scale actually you have to think of. So, log P2 by P1 or here actually P naught you can say CC multiplied by this will be the actual change. So, because of that you can find out this original void ratio minus change. So, that will be your void ratio, and we know another thing actually del H by H equal to del E by 1 plus E. So, from there I can find out delta H, that is nothing but consolidation settlement, will be equal to del E by del E multiplied by H by 1 plus E, and I can see that delta E from here I can find out delta E is nothing but E naught minus E will be equal to C C into multiplied by log P 2 over P 1. So, that means if I substitute here now that become delta E, if I substitute, then it becomes C C multiplied by H by 1 plus E log P 2 over P. That means, if a particular soil layer, if there is a soil layer and originally there was a pressure suppose P 1, and then because of foundation load etcetera it become P 1 plus delta P, which is nothing but P 2. Then how to find out the consolidation? I need to find out Cc of the soil, and I need to know original void ratio, and I need to know that this is actually P 2, this will be P 1. So, original pressure acting, and after foundation what is the pressure. So, that is the formula. That means, I can write separately here delta H equal to C c multiplied by H over 1 plus E log P plus delta P over P. So, this P is original pressure, and this is the pressure applied because of the foundation load. So, this is the formula, another formula, that means two formula we are getting. One formula delta H equal to mv dp and H, this is formula 1, and this is formula 2 for calculating the consolidation settlement. And here actually what you need? The coefficient of volume compressibility. How to get that? You have to plot the E versus P and then find out the slope of that, that is A over 1 plus E is the mv, and then pressure applied to the layer and thickness if you know, then you can find out this consolidation settlement. And second way actually we can do that log formula, it is called, and to apply log formula to find out the consolidation settlement, what you need? You need compression index. How to get the compression index? E versus log P you can plot, which you get a straight line, and from that straight line we can find out the slope of that line, which will be nothing but C c, and that C c, if you get C c multiplied by H by 1 plus E log P is the original pressure plus change in pressure divided by P, that formula, this is the formula 1. So, two ways actually you can calculate the consolidation settlement. For that obviously we require two different soil parameter, one is mv, another is C c. So, next sometime soil can be called normally consolidated, sometimes it is called over consolidated or pre consolidated. What is the meaning of it? Normally consolidated means it is a deposit in a particular deposit. This is suppose ground and this is how this is soil, and if you know the history of this soil and if you find that this soil layer never have been subjected to higher load than it is acting presently, then it is called normally consolidated soil. And if some soil, if you know the history of a particular site, then you may find that at some site soil already subjected to a higher pressure than it is at present. That means, under a certain pressure the soil already consolidated. So, because of that this soil may be called as pre-consolidated or over consolidated soil. What is the example I can give? Suppose at a particular site, suppose because of for some construction excavated some soil and it is dumped here for suppose 5 years, and then after some time this dump is removed. Then what happened, that last 5 years the soil here was subjected to a higher pressure than after removal whatever it is. So, that is the example of over consolidated soil. So, that when the soil is normally consolidated, sometime consolidation behavior is something, and if it is over consolidated the behavior is also different. So, because of that sometime you need to find out the pre-consolidation pressures if it is pre-consolidated. So, for that generally we do this, you can void ratio versus log pressure you can plot, and then we can find out a point of maximum curvature, and from there you can draw one horizontal, and this curve actually, and from that point you can draw a tangent. So, this point you have to select first on the curve portion, and you have to draw horizontal and you have to draw tangent, and then you have to divide this angle. When you draw a tangent and draw an horizontal, then it will make an angle at this point A, then you can divide this angle, and after dividing this angle and you will get a line AD, and then the curve E log P curve towards the end almost like a straight line, and that from the end of the curve you can again draw a tangent and produce back to the AD intersecting AD, then you get a point F. That F actually you can drop to x axis, and this value if you read, that is actually called pre-consolidation pressure. So, this is actually a graphical method of finding out pre-consolidation pressure, which is suggested by Krasegand, and still we use it. And if the soil is pre-consolidated, generally we model it EP curve sometime. Suppose there is a pre-consolidation pressure here. So, suppose this is one curve and this is another curve, though it is curved, but we can divide into two state part like this, and up to this we can consider pre-consolidation, and this is normally considered two segment, we can compute the total consolidation. So, this is the one actually, say if it is a over consolidated soil, and over consolidated, as I have told you that the curve it is over consolidated, something like this, curve is like this, and suppose PC, this is actually PC or pre-consolidation pressure PC, and suppose you have the site what is the effect present pressure, and applied pressure is del sigma, and sigma naught dash plus del sigma, the value if you calculate and if you find that is less than PC, that means the point comes somewhere here, then we can use this formula. This is nothing but recompression, actually this is the pre-consolidated portion. So, it is recompression taking place. So, because of that this slope of this line is called CR or recompression. So, CR into H by 1 plus E sigma naught plus del P, this formula is similar as normal consolidation, only instead of CC you will be using CR, that means slope of this portion. And then if you have sigma naught plus del sigma is greater than delta sigma PC sigma PC, that means if the point comes here, then you can use this formula. And this formula how we will do? I can first find out using the CR between this to this what is the consolidation settlement, and then from between this to this using CC what is the consolidation. So, that is the thing done here, using CR up to PC value this consolidation is taken, and beyond this use CC and use this formula, this part, this is actually actual consolidation and this is recompression. So, these two components together will be the total consolidation settlement when it is over consolidated, and that too sigma naught plus del sigma when it is greater than pre-consolidation pressure. Okay. Now, that consolidation rate of consolidation, that is called another important aspect, that you know that when it is a saturated fine grained soil subjected to load, then it will compress, but at what rate, that you can visualize this something like that. Suppose there is a tank and on that there is a piston, water totally sealed, and this piston supported by a spring, and what happen if you apply load here and there is no leakage, then if you apply load and then so this soil is the water is incompressible here. So, water will not compress, as a result whatever load you apply, this load is taken by the water as excess pore water pressure, and no load will be transferred to the spring. But if you allow a fine opening here and you apply load, then what happen, due to this loading, when this excess pore water pressure will develop, then water will try to come out from there and excess pore water will try to come to 0, and when it will become 0, then what will happen, whatever external load then it will, then some water is going out to make pore pressure 0, then what happened, the volume may reduce and come down here, then as a result then this load will be transferred to the spring and spring will undergo a compression. So, that is the way actually soil compression takes place. Now, if the opening is very small, then obviously the compression rate will also be very small, and if this opening is very wide, then rate will be very high. So, because of that we generally again rate of consolidation or degree of consolidation we are another way. That means, a particular site we know if I build something which is over a saturated fine grained soil, it will consolidate by some amount, but we then next question will be how long it will take. So, for that actually that there are some competition. So, we generally use there are time factor we use, and one term is time factor, which is CVT by H square, and this time factor is a non-dimensional thing, and CV is a coefficient of consolidation, which unit is meter square per time, suppose day, meter square per day. The CV unit is meter square per day. There are number of methods to estimate this one, and H actually the travel path, that means water how much distance is travelling to dissipate. So, that is the H, and T is the time. So, if you know the time factor, if you know the CV, if you know the H, then you can find out the T. That is one way, and T has a relationship with U. T has a relationship with U. What is U? U is the degree of consolidation. What is degree of consolidation? Suppose I know that what is the total expected consolidation settlement, suppose 100 millimeter. Based on that whatever method I have told, that I can calculate the total consolidation settlement, that is suppose 100 millimeter. Now, I want to know suppose if at some time the settlement is 80 millimeter, then degree of consolidation U is 80 by 100, that will be 80%. So, like that, suppose if the total settlement is 100 millimeter, I may ask, in my mind question may arise, how much time it will take to achieve 20% or 30% or 50% or 90% or 100%. So, that is some calculation, or I can also find out what is the time required to completely consolidate, 100% consolidate. So, that actually T versus U relationship we use, and T can be written in terms of U, suppose 20% or 30%, 40%. So, T versus U relationship is like that. This relationship valid when U less than 60%, and another T versus U relationship when U greater than 60%. So, that means, if I want to find out degree of consolidation, suppose 60% or 70% consolidation, how long it will take, then I will consider U is 70%, from there I will find out T, and then I will put T here, and if I know the CV of the soil and H of the soil, then I can find out the T of the soil. So, this is the way generally we find out the time, how long it will take to achieve certain degree of consolidation. And that, as I have told you, that H is the maximum distance the water to travel for dissipation. When the both sides are permeable, and if there is 2 H, then water actually at this point, water at this point, either it can go this way or it can get this way. When water is here, always it will go this way, because this is shortest path, it will never go this path. Similarly, when water is here, it will go by this path, not this in this way. So, that is why maximum distance the water has to travel is this half the thickness. So, that means, when there is a two sides both sides your shipping possible, then your H will be half the thickness of the layer. Whereas, if the clay layer is like this and it is impervious here and only permeable here, then water from here actually has to travel this much distance to dissipate. So, that is the longest distance. So, that means for this case you have to take the entire thickness as a distance, travel distance, and in that calculation. So, this is the application of this problem. So, this problem can be solved by anyone. I will not be able to take now this one, but I will just explain. The soft normally consolidated clay layer 15 meter thick like this, and with a natural moisture content of 45%, the saturated unit weight of 17, the gamma is 17.2, and the particle with this, and liquid limit is 65. Foundation will subject a 10 kilonewton pressure, that means delta P is 10 kilonewton per meter square, and this is clay layer is 15 meter. So, that means before application of the load at the middle of the layer, what is the effective stress you have to find out, that is delta sigma naught dash initially, and this del P is this. You have to find out that this value will be 17.2 multiplied by 7.5, and del P is this, and we do not know Cc. Cc can be approximately calculated 0.009 liquid limit minus 10. So, that will become 0.009 65 minus 10. So, it will come around 0.45 or so. So, Cc will be there, del P is here, sigma naught here, then you can apply the formula, delta H will be equal to Cc multiplied by H is 15, and 1 plus E naught, actually void ratio, natural moisture content is 45%, and if it is saturated, I know that S into E is W into G. So, this become 1. So, E will be equal to 0.45 multiplied by 2.68, that become E, and log here actually the sigma naught this value plus del P is this one divided by sigma naught dash. So, this formula if you use by this, those are the values shown here, then you will get the consolidation settlement. And similarly, if this consolidation, suppose if I ask that how much time it will take 50% of this to achieve, then you require actually CV, and suppose the value of CV is 4 meter square, CV value is given suppose 4 meter square per year. Then of course, using those formula we can find out how much time small t is required, you can find out. For that what you will do? You first find out, since I have told 50%, then using first formula you have to find out what is the value of t, and then t related to CV t by h square, that formula you use, CV is known, h is known, and capital T is known, only small t to be determined. So, this is way actually both time and total consolidation can be obtained. So, like this there can be several types of problem, and I with this actually I will just close review of soil mechanics, and from next lecture onwards I will start with shallow foundation and bearing capacity and all, and subsequently other topics. Thank you.